Hi everyone. In this video, we're going to be reviewing how to simplify rational expressions, multiply them, and divide them. Okay, so this is lesson 1-4, examples 2, 3, and 4. So first, let's talk about how to simplify. Step 1 is always to factor, and that's true for all three of these processes. You always want to start by factoring. Okay, so I'm going to start up here by factoring this entire expression. So in the numerator, I notice that this is a difference of 2 squares. If you don't recognize that, I did post another video on factoring and how to recognize a difference of 2 squares. But this factors into x minus 1 times x plus 1. And that is because these are both squared, and this is a minus sign. So the square root of x squared is x. The square root of 1 is 1, and then I write a minus sign in one of them and a plus sign in the other. So I just keep the 2 square roots, I copy it again there. One has a minus, the other has a plus. Now, for the other expression, this is a trinomial, and there is no number in front of my x squared. So I need something that multiplies to negative 2 and adds to positive 1. And that's x minus 1 and x plus 2. Now, the last thing I need to do in just a simplifying one is just reduce anything that repeats. So this x minus 1 is up here and down here, so I just reduce it out. It just gets crossed out, and this is what I'm left with. So I get x plus 1 over x plus 2, and that is my result. Okay, so you always start out with factoring, and you always want to reduce. Okay. Example 3, surprisingly, will work almost exactly the same as example 2. I just factor every single expression here. I cross out everything that can reduce, and then I write it all just as multiplication. I just rewrite it into one big fraction. So in this one, this is a trinomial. I need something that multiplies to negative 3 and adds to positive 2. So that's x plus 3 and x minus 1. In this one, I need something that multiplies to 16 and adds to 8. So that's x plus 4 and x plus 4. Now I could write it as x plus 4 squared, but I find that when I do that, sometimes I accidentally cross out the whole thing when I'm reducing, when I really only mean to cross out one of those terms. So I usually don't put the squared on there because it kind of messes me up sometimes. So I'll put the multiplication. Now I have 3x plus 12 here, so I'll factor out a 3, and that's just factoring by a GCF. Okay, and then in the denominator, this can't be factored at all, so I have x minus 1 there. So now again, I'm going to look for terms that can reduce. This x plus 4 can reduce with one of these down here, and the x minus 1 can reduce with that one. So now I'll just write the leftovers. Whatever's left over just gets multiplied together in the numerator, and anything in the denominator just gets all multiplied together. So this is going to be 3 times x plus 3 over x plus 4. Okay, so you always begin by factoring, you reduce, and then you can multiply or divide as necessary. So in this case, I'm just going to put multiply here. Now, division is the one where I would say you would probably want to just add an extra step at the beginning. And that extra step is the thing that we do for fraction division. When you're dividing with fractions, you flip the second fraction. So I would put up here for division, flip the second fraction. And I like to do that first so I don't forget to do it later. So my expression, I'm just going to move this up so I don't accidentally go off the board. This is going to flip. So I have x minus 4 over x squared minus 4 times x squared plus 5x plus 6 over x squared minus 3x minus 4. Now I'll just factor these expressions. X minus 4 can't be factored. This is a difference of two squares. It becomes x plus 2 and x minus 2. This can be factored to x plus 3 and x plus 2. And this can be factored to x minus 4 times x plus 1. Now I'll just reduce. X minus 4 can reduce with the other x minus 4. X plus 2 can reduce with the other x plus 2. Now, finally, I'm just going to multiply everything across. So anything that's left over gets all multiplied together. And don't forget, you have to keep the things in the numerator in the numerator. The things in the denominator belong in the denominator. So that is my final answer. Now, you'll notice with all of these answers that I didn't actually complete the multiplication. I left it in factored form. That is acceptable for these types of questions. Some people will like it to be multiplied together, but for our purposes, we're not going to do that. So make sure you ask me if you have any questions about what's going on here.